every time your washing machine starts, every time your car unlocks, and every time your smartwatch vibrates. A tiny computer makes thousands of decisions every second. That tiny computer is called a microcontroller. Today let us open up and see what is really inside a microcontroller. CPU, flash, RAM, peripherals, GPIO, and power management. What is the CPU? Every microcontroller has one important component that controls everything. It is CPU or Central Processing Unit. Think of the CPU as a brain of microcontroller. Its job is to execute your program by reading instructions, processing them, and controlling the other hardware inside the microcontroller. Whether it is blinking an LED, reading a sensor, or communicating with another device, every task is coordinated by the CPU. In simple words, without the CPU, a microcontroller cannot do anything. Inside every CPU, three important components work together to execute your code: the ALU, registers, and the program counter. First is the ALU, or arithmetic logic unit. It is the calculator of the CPU. It performs arithmetic operations like addition and subtraction, logical operations like AND, OR, and comparisons, all in just a fraction of a second. Next are the registers. These are tiny, ultra-fast memory locations inside the CPU that temporarily store data and instruction while they are being processed. Since they are built into the CPU, they are much faster than RAM. Finally, there is the program counter or PC. It always stores the address of next instruction to execute. After each instruction finish, the program counter automatically updates the point to the next one. What is the flash? Have you ever wondered where your program is stored after you upload it to a microcontroller? If you disconnect the power and turn it back on, how does it remember your code? The answer is flash memory. Flash is the permanent memory inside a microcontroller. It stores your firmware, bootloader, and constant data. Unlike RAM, flash keeps its content even when power is turned off. When you compile your C program, it is converted into a firmware file. During programming, this firmware is transferred through USB and written into the microcontroller's flash memory. Once the programming is complete, your application is permanently stored there, even if you turn the power off. What is RAM? RAM, or Random Access Memory, is the microcontroller's working memory. It temporarily stores the data your program needs while it is running, such as variables, function calls, buffer, and a stack. For example, if your program reads a temperature sensor and stores the value in a variable, that variable is stored in RAM. Every calculation, every function call, and every temporary piece of the data uses RAM while your program is running. But unlike flash memory, RAM is volatile. The moment power is turned off, everything stored in RAM is erased and it starts completely empty the next time the microcontroller power on. What is peripheral? Peripherals are the built-in hardware module inside a microcontroller that allow it to interact with the outside world. Instead of writing everything in software, these dedicated hardware blocks perform specific tasks quickly and efficiently. For example, UART is used for serial communication with a computer SPI and I2C connect sensors and display. ADC convert analog voltage into digital value, and PWM generates precise signal to control LED and motors. These peripherals work alongside the CPU, making the microcontroller faster and more efficient. What is GPIO? GPIO, or General Purpose Input Output, are the physical pins of microcontroller. They allow the microcontroller to communicate with the outside world by sensing or receiving digital signal. As the output, GPIO pins can turn an LED on or off, drive relay, or control a buzzer. As an input, it can read the state of push button, detect a sensor signal, or monitor other signal. In simple words, GPIO pins are the bridge between microcontroller and real world. What is power management? Power management is the part of the microcontroller that helps reduce the power consumption and extend battery life. It controls how much power is microcontroller uses in different operating mode. For example, when your program has nothing to do, the microcontroller can enter sleep or deep sleep mode, dramatically reducing its power consumption. It wakes up only when an interrupt or time event occurs, allowing battery-powered device to run for months or even years. That's why efficient power management is essential in wearable devices, wireless sensor, and IoT application. And that's what makes microcontrollers so powerful: a CPU to execute program, flash to store it, RAM for working data, peripherals to communicate, GPIO to connect with outside world, and power management to maximize battery life, all integrated into a single chip, that is microcontroller. So friends, I hope you enjoyed this video. If you really like this video, so please do like, subscribe and share. Thanks for watching.